Hello, my name is Kate Schutz, and here is my presentation of my first lab. The purpose of this first lab was to compare the observed velocity of a moving object to the predicted motion of the same object. The predicted motion was calculated through a coding program. For the experiment, a cylinder was rolled across the floor, and the position, time, and velocity of the cylinder were recorded using a program called Tracker. The cylinder itself is the system, and the surrounding forces are gravity and the floor. In this case, friction is negligible. The principles used in this experiment were Newton's second law and the momentum principle. The position update formula was also used. In this experiment, the object moved a total of 0.04. In this experiment, the object moved a total of 0.406 meters after 1.64 seconds. The net force of this object is 0 because the object is not changing in acceleration. Since the net force of the object is 0, the velocity of the object is constant during the motion, according to the momentum principle. The velocity of the object was calculated to be negative 0.3003 meters per second by using the momentum principle. The equations used in this lab were the momentum principle, a derived equation from the momentum principle that gives you the final velocity if you have the initial velocity of an object, Newton's second law, the position update formula, and the velocity formula. Here is the video of the object's motion that I analyzed. Next, I wanted to show you some raw data from my experiment. I gathered this data using a program called Tracker. Using Tracker, I calculated the object's time and position during each frame of the video. All length calculations were made relative to the diameter of the object, which measured 0.05 meters, and were all taken from the origin of the coordinate axis, which I placed in the center of the object during the first frame of its motion. In order to calculate the velocity of the object, I took the position from the first and second frames, and the time from the first and second frames, and inserted them into the velocity equation. The result was that the velocity is equal to negative 0.3003 meters per second. In this next slide, you can see a graph comparing the observed motion of the object with the predicted motion of the object. The computational model predicts that the motion of the object will continue at a constant velocity. Since the cylinder is experiencing no acceleration, the net force is equal to 0 according to Newton's second law. So if F net is 0, then the velocity is constant according to the position update formula. Now, as you can see from this graph, the observed motion, the blue line, differs from the model slightly, starting at around 0.5 seconds. After 0.5 seconds, the observed velocity is slower than the model velocity. This situation could be a result of friction or air resistance, neither of which were accounted for during the calculations. If friction and air resistance were acting upon the cylinder, then the F net would not be 0 and the velocity would not be constant. Also, another interesting aspect of this graph to consider is if the coordinate axis was reversed. If the coordinate axis had been flipped so that the motion of the cylinder was moving toward the positive x-axis, then this graph would have reflected over this x-axis here, and the velocity would have been positive, but the numerical values wouldn't have changed other than their sign. The next slide goes into the code I used to create the computational model, the predicted motion. I was given a starter code, and after I downloaded the starter code, I updated the mass, the velocity, the position, the time, and the net force. I also changed the velocity and position equations on lines 58 and 60 to better reflect the momentum principle and Newton's second law. The result of this code and the changes I made is that it creates a loop predicting an object's future velocity based upon their initial conditions. In conclusion, the observed velocity and model velocity were similar, although there were some differences. The differences could have been caused by air resistance or friction, both of which were not calculated into the velocity in this experiment. Also, the experiment could be improved upon by calculating the velocity anew through observational data at several points throughout the object's motion. Thank you.